All right, I'm ready. 9-6 dilations. We've talked about these before, but we're going to actually do some of our own today. So dilation, we've talked about it before, right? Your pupils dilate or whatever. So a dilation is a transformation that changes the size of a figure by a scale factor k. So we've talked about an enlargement, we've talked about a reduction. We sort of talked about a congruence, but we didn't put a whole lot of math in it. So an enlargement is when the scale factor k, the absolute value of it, right? Because I don't care if it's a negative, where the k is bigger than 1. For example, we sometimes had like a 2 or something like that, doubled in size. If it's in between 0 and 1, if it's a fraction like 1/2 or 1/3 or 1/4 or something, it's a reduction. If it is 1, it's a congruence. They're the same, okay? To do it, you take x comma y and you multiply both of the x and the y values by whatever the constant k is. So if I said it was 2, I'm going to multiply both the x and y by a 2. Is that okay? Okay. Let's do one. Draw the dilation image under the given scale factor. So here's what you need to do. First, you're going to use your ruler as a straight edge. We're not measuring anything just yet. So you're going to use it as a straight edge. And you're going to draw a working line from S to each of the vertices of this rectangle. Okay, I'm going to do it too, but obviously I'm not using a ruler, so be nice. Ooh, nope. Sort of. Something like that, but straight would be great. Okay, you go from S, make it longer than you think, so extend it past the vertices of the rectangle. Okay. Ish. I'll erase that one. So right now you're just using the ruler as a straight edge. Okay. Nothing fancy. Go from S to the corner to each corner. Make a line. Okay. From there, if our scale factor is 2, is this a reduction or an enlargement? Enlargement. It's going to get bigger by twice as much, right? So what you need to do, you can use inches or centimeters. I don't care. Do whichever one's easier for you to measure. I think the last class determined that centimeters was easier here. So see how far it is from S to this corner. Let's just pick centimeters because that's what they did. They thought it was easier. So about how far is this? Don't give me like 2 1/8. Let's just do like 2, 2 1/4, 2 1/2, something like that. You guys thought 2 1/4? Okay, they thought 2. Is it 2 1/4? What do you think? You think 2? Okay. Let's, just for the sake of being easy, let's just say it's 2. Okay. So from here to here we think is about 2. So if I want to dilate it double the size, how far do I need to go from S? 4-ish, right? So from here on this line, I need to go to 4 centimeters and put a dot. Obviously, I don't have a ruler, so I'm just guessing. So you put a dot where the new vertex is going to be. It was here. On this line, it's going to be here. Okay? So from S to this corner, about how far do you guys think that one is? You guys think 3? Okay? So if this is 3, how far do I need to go? Bless you. 6, right? From the S, you need to go to 6 centimeters. And again, it's not perfect. I'm not making you be super precise. I'm not making you do 2 1/8 or anything, so it's going to be pretty close. From S to the lower left corner, what are you guys getting? 2 1/2? Okay. So if this is 2 1/2, how far do I need to go? 5. And then from S to this corner, 1 1/2. I think that's what they got to. So how far do I need to go down here? To 3, right? Once you get all those dots, take your time, make sure you get it right, all right? You're going to connect them with your straight edge again. You're going to be as, whoa, you want to do as good a job as possible, right? If you have a ruler, which I don't. And you connect the dots. So when you connect the dots, this is my new figure with a dilation of 2. It should look about twice the size of the first one. Okay. Once I get you guys started on the second one, I'm going to walk around and just kind of glance over your shoulder and let you know if you're super far off. If you're fine, I'll just kind of walk by, okay? If you ever want to check something like that with mine, obviously it's right up here in my binder. You could get up, takes 2 seconds, and look at mine and be like, yeah, it kind of looks like what I did. Okay? All right, so for the next one, you're going to start it the same way. You're going to start at S and go to each corner. Because this is a dilation of 1/2, what's that going to mean? It's a reduction, right? So do I have to go past these corners, or can I just stop at the corners? Stop at them, right? You don't have to. If you want to go past them, that's fine. I just think it's a little messy when we do that. So you're going to go to each corner again, draw your straight line-ish. Measure again, but I think the first one we said was 2. I think we said that was 3. I think we said that was 2.5, and I think we said that was 1.5. So you're going to go half of those. So if this was 2, you're going to go to 1. If this was, what did you guys say that was 2.5? Did I remember that right? That second one? What's half of 2.5? 2.5 divided by 2. Well, 1.25. Oh, is it 3? Oh, I'm remembering it wrong. I'm sorry. You're right. It was 3. So 1.5 is where we want to go. You're right. It was 3. I remember that now. The next one was 2.5, which we still had to figure out half of that. What's half of 2.5? 1 1/4. Yeah. So go 1 1/4. What was this one? 1.5. Is that what you guys got for that last one? Was it 1.5? Okay. So then what's half of 1.5? 3/4. Very good. So you connect those dots, and it should look like it's about half as big. Okay, so like I said, I'm going to walk around just really quickly and glance over your shoulder, but if you want to come and look at mine, you can. Okay, if you have a question, let me know. So if you draw your lines all the way out and then do it, they won't chunk like that. You see what I'm saying? So it's okay, don't do it again. This one looks right. So you're all right. Are you okay? One and a half is here, so we go half that. So like that is right there, right? Yeah, everybody's looks good. Okay. Again, if you want to check it with mine, you can. Okay, next question. Determine whether the dilation is a reduction or an enlargement, then find the scale factor and x. I didn't draw it for you. I can sketch it real quick-ish. Something like this. And then we had F was down here. And we knew this was W and this is W prime, right? This is 4.5. This is X. This is 9-ish. Obviously your picture's better, but that'll do, right? So first of all, if this is W, that means this shape was the W, okay? This is W prime. On your picture, it's better. Is it a reduction or an enlargement? It's an enlargement. On your picture, it's obvious that this one was bigger than that one. Not on mine, sorry, but you're all right. Okay, so an enlargement, that was one of the questions. Check, right? Another question is find X. Well, if this is X, and this is 4.5, and this is 9, what's X? 4.5. All right. Easy, right? 9 minus 4.5 is 4.5. That's the second answer. The third answer was find the scale factor. So we have to go back a little bit. One option was this new over old. Some of you guys chose to use that. Some of you didn't. So if you want to do new over old, I'll show you that in a moment. Some of you guys just found the scale factor and you're like, okay, is that 1 to 7 or is it 7 to 1? You kind of like thought about which one made sense. So if you're going to do the new over old, what's the new length? The 9. What's the old? The 4.5. Do you guys understand that? So what is 9 over 4.5? 2. So technically, my scale factor is 2 to 1. If you're someone who didn't like that formula, what you guys did was you said, okay, it's an enlargement. So is this a 2 to 1 or a 1 to 2? Larger first, 2 to 1. Does that make sense? Is that ringing a bell for you guys? Do you remember talking about that? Okay. Did I lose anybody there? Mm-hmm. Yeah, for sure. You can look at it and say it's an enlargement. That's what most of you guys did the first time. You looked at it, you said enlargement, and then you did your fraction and you weren't sure if it was 2 to 1 or 1 to 2. And you said because it was an enlargement, the larger one comes first. So you said, oh, just kidding, it's 2 to 1. Now, some people chose this way. I think most of you guys didn't. I don't remember though. Is that all right? Okay. Yeah, especially if you look at your picture, it was obvious to tell it was an enlargement without doing any math. All right, find the image of each polygon with the given vertices after dilation, centered at the origin with the given scale factor. All that's saying is find the dilation final answer. When it says dilation centered at the origin, they're just trying to be specific and let you know that you can go back to that kx comma ky formula. The reason for that is it doesn't always have to be centered at the origin. So if it's not centered at the origin, this rule may not work for that question, but it is. So we'll just use the rule. Okay. So if these are my original ordered pairs and k is a third, I'm going to multiply, again, if you go back to that first slide I had, I'm going to multiply all the x and y values by the constant k. So if I multiply each thing by a third, what's that the same as? Dividing by 3, right? Same thing. So what's a prime going to be? 9, 9 turns into 3, 3. B prime turns into 1, 1. C prime turns into 2, 0. That's it. Anybody confused at all? Okay. On the homework, you're going to need a ruler for the first 2 questions, just like we did on our first 2, but other than that, you won't. Okay? Let me know what you need if I'll ask you. Hold on a second. Let me save this and I'll let you know.